everyone. Welcome to this online EDU-ARCTIC lesson today on the risk of tsunami in the North Atlantic Ocean. My name is Lis Mortensen, and I am a physical geographer. Let me tell you a little bit about myself. I work at the Jarðfræðingi, which is an institution in the Faroe Islands. It is the geological survey of the Faroe Islands. As a physical geographer, I work with landscapes on land and a little bit on the seabed as well. And I have worked with what do we call it? The tsunami hazard in the area of the North Atlantic Ocean. With what is the risk in this area of a tsunami, and we have there's a group established in the Faroe Islands where we can where we are part of a European network working with this kind of hazard. So I'll tell you a little bit about this. While we are talking, you are welcome to ask any questions on the chat, and I will, as good as I can, try to answer it. And I have a little bit of help with Gunley here today, so we can see if you have any questions. And Khrushchev is hosting the lesson as well. The concept of a tsunami was not so well known probably until 2004. In 2004, the world saw the very, very bad catastrophe of the tsunami in the Indian Ocean, hitting the countries around the Indian Ocean, especially Indonesia, Thailand, all the Sri Lanka, all the way around the many countries in the Indian Ocean, and further even than that. In Africa, for instance, it hit as well. So after that catastrophe, where more than 230,000 people died, the world really learned the concept of what is a tsunami. And they are very rare incidents, and sometimes they are very, very bad catastrophes that can happen in coastal areas. We still remember the very devastating catastrophe that hit Japan after the earthquake in 2011. I will talk a little bit about what is a tsunami, what causes these incidents, how this has showed us the need for a tsunami warning system, and I'll say a few words about the tsunami warning system in the North Atlantic Ocean, and I'll talk just in the end about what can I do, what can you do, what can we all do when we're in an area hit by a tsunami. In the middle of the lesson, I will just have a short question, and we will end the lesson with a Kahoot game. What is a tsunami? Let's begin by looking at that. A tsunami is a series of giant ocean waves. They are often caused by earthquakes, by landslides. They can be also caused by marine slides, where there's sediments on the seabed that starts sliding down along break. And they can be caused by volcanoes, and in geological knowledge, we know that they can also be caused by meteorites. These are giant waves that can travel very, very fast. When we see the first image here, the upper image here, we can see that this is a tsunami situation, a place where we have two earth plates that meet, and with my arrow here, it shows where these two earth plates move against each other, and there's an earthquake where one earth plate is lifted up as the other earth plate is sliding downwards, and when one of the plates is lifted up a few meters, that can set begin a movement in the whole water above that place hit by the earthquake. So it rocks the ocean floor and displaces the volume of water, pushing the volume of water upwards. This sets off an oscillation of the water, which where you have water moving away, in all directions from the earth plate, from this place that was hit by the earthquake, and we can see these waves moving. In both directions. They move towards land and they move outwards, and especially when they move towards the land, the giant waves, they travel very fast when they are in the deep water, but as they move closer to land, they start lifting up. They get higher. We can see it in the third picture, that the waves get bigger as the water gets shallower, and depending on the shape of the coast, in some of these places the waves can get very, very high. Not in all places, but in some places. And what is special also with these waves, giant waves, where the whole volume of water is moving, is that the waves are very, very, very long, and so that when they move towards land, it seems people describing these incidents say that it seems like the ocean took a direction like a river towards the land and just started running and running towards the land. here. The tsunami waves, they travel very, very fast. When they are in deep water, like 5,000 meter deep water, they can have the speed of a jet plane, about 800 kilometers an hour. When they move closer to land, to more shallow water, for instance, around 500 meters depth, the speed of the wave can be around 250 kilometers an hour. And as it gets more and more shallow, when the water depth is around 100 meters, the speed of the wave is still very, very fast, about 110 kilometers an hour. And as it gets into very shallow water, it still is so fast that it can outrun people. And that's one thing that makes these waves so extremely dangerous. The causes of a tsunami are, as we mentioned in the beginning, there are many causes, but most of the tsunamis that we know about are caused by earthquakes. These are earthquakes that happen in the underground beneath the seabed. These earthquakes tend to be stronger than 6.5 on the Richter scale. They are shallow beneath the seabed, which means they are just a few kilometers beneath the seabed, which is quite shallow. And another thing that's necessary for the whole volume of water to begin moving is that the earthquake has to cause a vertical movement of the seabed. When that happens, then the earthquake can result in a tsunami. And then these earthquakes, when all these things happen with an earthquake, these are the causes of in between almost 90, between 82 and 87% of tsunamis are caused by earthquakes in this way, and the rest of the tsunamis, they are caused by landslides, by where you have maybe a big landfall where you have a lot of material that falls into the sea, and that causes a tsunami. And you can have marine slide, you have material on the seabed that slumps down a marine downwards to deeper water, and you can have volcanic eruptions, and you can have meteorites. The image on the page here shows events that are recorded in the time period between year 1600 and 1969. And you can see for the North Atlantic Ocean what areas most frequently cause tsunamis in this region. And as we later will hear, this is our region is one of the regions in the world where tsunamis are probably most rare. This map shows the location of tsunamis that are recorded over a period of time of maybe 20 years. We can see that they are not really even located all over the world. We can see that most of the tsunamis, They are located around the Pacific Ocean, and we can see that if you follow my arrow here, it's around the area that in geological context often is called the Ring of Fire, which you will hear in a bit. And we also have a lot of tsunamis here in the Indian Ocean. And there are a number of tsunamis in the Mediterranean Ocean, but actually, if we look at the area in the Atlantic Ocean, it is quiet, more quiet than in some of the other regions in the world. Here we have the devastating catastrophe that happened in the Indian Ocean in 2004, and we can see how that tsunami, which was caused by an earthquake in the Indonesian area, here in the Indian Ocean, caused the tsunami that distributed that was a very, very bad catastrophe for the whole region around the Indian Ocean. The Aceh region in Indonesia, after the tsunami in December the 26th of December in 2004, the area was really, really hit bad, and it is estimated that about more than 230,000 people died in that catastrophe. So based on what we have just heard, I would like you to just think a little bit about what could cause a tsunami. Do you think it could be very strong wind, very hard tidal currents, which are hard, very hard, for instance, in the area around the Faroe Islands, but in many regions in the world you can have very, very hard tidal currents. Could thunder cause a tsunami? How about landslides, marine slides, and earthquakes? Earthquakes are a bit easy question since I've talked so much about earthquakes. But what do you think about the other causes? Do you want to guess a little bit? Yeah. So the point is that it is necessary, if a tsunami happens or develops, that the whole water column, and not on shallow water, but actually on quite a little bit deep water, so not just by the coast, but it has to be quite deep water, is displaced. You have to displace a lot of water, and that wind cannot do that. Wind does only displace the upper little portion of the water, not the whole water column. And the same thing we can say about tidal currents. They are not quick enough to cause a disruption, a displacement of the whole water column. And the thunder obviously is not big enough either to be a cause for a tsunami. We need something like a landslide, a marine slide, or an earthquake that somehow can cause something that displaces the whole water column. We were looking earlier about at the tsunami events. Where do they happen? And we were looking at that they were most common in the Pacific Ocean. They are quite a lot of tsunamis also happen here in the Mediterranean Ocean. And then in the combined North Atlantic Ocean, or combined Atlantic Ocean and Caribbean Sea, we have about 9% of the tsunami events in the world, and about 6% of the events happen in the Indian Ocean. When we look at this distribution and then look at the next map, we can see why the tsunamis are distributed like this. Most of the tsunamis that we see in the world, they are caused by earthquakes. So when we say that about 87% of the tsunami events, the significant tsunami events, they are caused by earthquakes, both when the seabed moves and displaces the whole water column, but also these earthquakes can result in landslides. So these incidents tell us that it is along these areas where these earthquakes happen that most tsunamis are found, and that's why they follow approximately the same regions where earthquakes also happen, which is around the boundary where the earth plates meet, the boundaries between the earth plates. That's the distribution both of tsunamis, because that's where the earthquakes happen. And in this, knowing all this, the world, in many places, there have been established tsunami warning systems. There's a tsunami warning system in the Pacific. It's called Pacific Tsunami Warning Center, which looks out for the whole Pacific Ocean and probably is the oldest of these established systems. There is the Indian Ocean Tsunami Warning Center, which was established after the catastrophe in 2004. There is the Caribbean Tsunami Warning Center, where actually a number of tsunamis also happen. And then there is the new system in the Northeast Atlantic Ocean, which is for the Northeast Atlantic Ocean, the Mediterranean, and connected seas Tsunami Warning Center. And then many tsunamis happen over here in Japan. So there's a regional tsunami warning system for the region of Japan. And we looked a little bit at the Atlantic Ocean, North Atlantic Ocean, Northeast Atlantic Ocean, where the area where we are right now, at least. And one of the very bad catastrophes that is being looked at as something that maybe could happen again. It is an area west of Portugal, where there was an earthquake in the 1st of November in 1755, where Lisbon, where Portugal, was hit by a very bad earthquake, and shortly after that, a tsunami was the area was hit by a big tsunami wave as well, which destroyed very big areas in that area. Another very big tsunami event was in the North Atlantic in prehistoric time, where there was a marine slide west of Norway about 8,200 years ago. So these are the big events that we are learning from. There are many other smaller events that are very important as well. Um, and these events have been the basis of saying, well, if we know that although the North Atlantic Ocean is not hit often by tsunamis, it certainly happens, and therefore it is important for that area and for the Mediterranean and connected seas area, for like the Black Sea, to be part of a tsunami warning system, which at the moment is the center of it is in Lisbon in Portugal. These tsunami warning systems, they have two components. They have a network of sensors to detect tsunamis. As we see on this picture, we see something that detects and sends up to a buoy that where the data is relayed to satellite. And then it also needs a quick communication of alarm to the coastal areas. In order to build all this up, both the sensor part of the tsunami system, which is obviously very important, but also the communication to get this message out to the whole region. There are regular exercises conducted. The last exercise was done here the 3rd of November in 2017, a bit more than a month ago. It was called NEAM Wave 17, and the idea with this exercise was to have imagine there was a tsunami out west of Portugal, and how would these warnings be distributed out, sent out to the whole region. And in all these countries there were these centers that received the message. They were ready and were testing and exercising how does it work to distribute the communication about the tsunami alarm. The tsunami warning systems, they are obviously very, very important. But it's also important that we are all aware of tsunamis and how to best protect ourselves. So every year on the 5th, this year it was the 5th of November, there is a Tsunami Awareness Day, an International Tsunami Awareness Day, where people are encouraged to think about, what should you do if you are in an area that is hit by a tsunami. And the general message is trying to make it as simple as possible. If you feel there's a strong or long earthquake, the ground shaking severely, then look out and see, maybe you can spot unusual disappearance of ocean water, or you can see the water is coming in a strange matter onshore, or maybe a wall of water coming onshore. And if you hear a loud roar similar to that of a train or an airplane when you're by the coast, then leave the coastal area, run away, leave the coastal area and move to higher ground or inland. So these are some of the signs of a tsunami that you should be aware of. With these, I'll say thank you for listening to this lesson about the tsunami warning system.